Welcome guys. Welcome back to the lesson 7. Uh, today's today's topic will be testing and deployment uh, of the contracts. So similar with the Tuesday lessons, I will try to keep my lesson short to save your time and keep it simple. Yeah. So yeah, let's start. All right. So for today, we will cover those topics. So first, we will learn how to deploy what is the deployment and how to deploy the contracts to the Kairos testnet or even mainnets. And also we are gonna run testing. What is the test and testing strategies and frameworks. Uh, and third, we're gonna learn contract verification. So what is the verification and why it matters, and how we can verify contracts on like Kaia scan or either scan or other verifiers. And we are gonna learn some security things like common vulnerabilities, like common security issues, and how we can prevent them. And we have exercise, homework. So let me introduce at the end of this lesson. Yes. So yeah, let's start with deployment. So deployment means, as you might not know, it means publishing smart contracts to blockchain. So for example, on Kaia, when you build some smart contracts, you need to deploy those contracts to testnet or Kaia mainnet to make them be used in dev like mini devs. So for goals of deployment are uh, is basically we want to ensure correct setup, like we want to make our parameters correct and be correct, and also got other gas prompts too. And we might want to test on test nets like before deploying to the mainnet, because of course you can test it on local blockchain network, like using hardened node or unveil in Foundry, but it works. But for the production level development, then it is highly recommended to test on testnets too, because testnet is basically uh ha- for is exist for testing purpose before going to the mainnet. So, and it mimics the features of or the features of the mainnet. So you must test on the test net before uh going live to the mainnet. Yeah, and also we can verify. I cover this later anyway. But and we can verify for transparency. And there are some tools for deploying contracts like Hardware Ignition and Foundry and other testing config. So let's dive into those topics. So hardware ignition is Hardware's new deployment system. So the difference is more like declarative, and is more like uh, from my perspective, is more developer friendly deployment system than the old system of Foundry. So you can install the hardware ignition by this command So basically, you can npm install using npm install to install it, and you can import this hardware ignition at the top of the source code. So this is the script for deployment using hardware ignition. So you can set the gas parameters and constructor arguments, and then you build module. Build module is basically method from the hardware ignition library, and then you can set the parameters, and you can just declare this contract. Or in this case, we are gonna deploy the lock contract, which is the basic template of hardware framework. So you can just declare like this, then it under the hood it deploys the lock contract to the testnet or mainnet, depending on the configs. So yeah, and you can learn the script by learning this command npx hardware ignition deploy blah blah blah, and you can set the network config, and deployment ID is for just identifying the deployment object. So of course, there is other way to deploy contracts on hardware, and it actually really doesn't matter uh, whether you use this ignition or older version of the hardware deployment system method. So yeah, it really doesn't matter. So let's you can use anything for deployment. Yeah, it doesn't actually there are no fundamental differences since those two things are or exist for deploying the contract. And we can also deploy via Foundry the contracts. And in Foundry, luckily I mean, its Foundry is, as I mentioned in the last session, Foundry is written in Rust, and it natively support Solidity for everything. I mean, aligning contract code for sure, and testing, and scripting, and any other things. So you can deploy, unlike the hardware ignition. So in this case, you should write in some JavaScript or TypeScript code to deploy the contract, but you don't need to use other languages anymore in Foundry. So you can keep using uh, only Solidity to deploy the contract. So in here, we can set some environment variables like Kairos Tesla RPC URL and private key for the deployer of the deployer. And yeah, we set the config, and we can just declare new counter. By the way, counter is just the random, just the basic template contract of the Foundry framework. So anyway, so you can just like what you can do in Solidity code when you uh want to deploy some contracts in Solidity code, you can use this new keyword for the contract. So likewise, you can just declare new counter contract, and it deploys the contract, and it returns the counter's contract object. So and you can log the address, counter contract address like this, because it's Solidity. So yeah. So for deploying contract by Foundry, it's more simplified code. By the way, is actually same code. Anyway, uh, you can learn this command to deploy the contract like for the script. script blah 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 blah, and you can set the RPC URL for sure and private key for sure. Yeah, but you can set you can set the environment variables for sure. Yeah, you don't need to you don't I mean you don't need to pass those private key or RPC URL manually every time. Yeah. So for deploying the contracts to the testnet, you must set the configs before the deployment. So for hardhat in the like what I mentioned in the last lesson, you have some hardhat.config.ts file. So every config things are in there. So you must set the Kairos testnet config in here if you want to use it. And for Foundry, you can set the environment variables in foundry.yml file. But there is one caveat here. So for Foundry, you could encounter some errors regarding the gas phase error. So when you try to deploy the contract with Foundry, you may encounter this error like contract creation code starting out of gas. It basically means the deployment the transaction uh the gas limit of deployment the transaction is not enough to cover actual gas cost. So in this case, why this happens? Because there is a default setting for gas estimation algorithm in Foundry. Default the 130% multiplier setting, but sometimes on Kaia networks like Testnet or Mainnet, this could not be enough. So so for so fix this issue, you can set manually the gas multiplier rather than use the default setting. So like this, uh when you learn the deployment script, you can set the chain RPC, but those things are those things don't matter. But you can set here gas estimate multiplier like 200, then it will set the gas estimate multiplier bigger than the default setting, larger than the default setting. So it should be okay to I mean fix this error. It's annoying, but there are uh there are no other smart ways, more convenient ways, as far as I know. So yeah. So yeah, that's it for the deployment. Now is time to learn about the test. So test, what is the test? Why do we need test? So as I mentioned in the last lesson, the smart contracts are fundamentally immutable and high stakes because there are lo- usually usually they have large funds at risk. So if there are some bugs or security issues in the contract, uh if those contracts are not upgradable, then there are not much things that we can do to handle those cases. So because of that, we need to test thoroughly the contracts before the deployment. So there are many types of testing. So unit testing, integration test, and fork, fuzz. So for the unit test, it's very, very basic and simple test. Usually after you develop some contracts, you must write down the unit at least you must write down the unit test before the deployment. It's minimum requirement. Yeah, so you must do it. So what is the unit test? Is because it's basically uh test the unit functions of the contract, like you can like test code for each function or each features, like yeah. So that is the unit test, and you can see the unit test code in the our starter boilerplates that I shared in the last session. And the integration test means, as you might know, might not know, but anyway, is the more integrated test. Is basically uh like some tested scenarios to cover uh core core functions of the system itself. So let's say, for example, let's say we will build some Uniswap, like simple DEX for contracts. Then unit test would be testing each function, like swap function or withdraw function or routing function. But in the integration test, you must test uh, whole functions, like from starting point to like users triggers the swap function, and then it allows to uh pull contracts and then swap it under the hood, and then users can get the tokens. So you must test the whole user full scenario for preventing any issues beforehand. So, and the next is fork test is very important, actually, because in usually we do test on local network, and local blockchain network is very convenient and easy to use and test. But uh, sorry, but when you want to test against the mainnet state, um, let's say you want to use some users some whales balances to test, then in the local network, it's very hard to uh, get this. Actually, technically, it's possible, but it's very verbose and uh, it's very verbose. But anyway, you can get the mainnet state directly for this test code to test against the mainnet state. It's very convenient, and in some cases it is very necessary testing method for some cases. Yeah, and the last one is fuzz testing. Is basically testing. Uh, if you are already familiar with computer science and testing methodology, then you might heard of what the fuzz testing is. What the fuzz testing is, then is basically testing with random inputs. Like let's say in the unit test, you just input let's say we get some random number like 100. The unit test, you can only input just 100 in the test code, like hard coded. But we might want to test with uh thousand or more than thousand inputs, millions, billions inputs. For numbers like one to billion. So from zero to billion. So in that case, fuzz testing helps uh to cover those cases. So yeah, let's dive into each topic in the next slides. So for the fork testing, as I already explained what the fork testing is, why it matters. So to do fork testing in Hardhat, again in the hardhat.config.ts file, you can add this forking uh forking object here. So you can set the URL like you you might want to test on mainnet Kaia mainnet states. So you can set the URL like this, and you can set the block number, specific block number that you want to test against. So if you don't want to set this block number, you can remove it, and then it automatically uses the latest block number. Uh, but in most cases, I'm not sure if I remember correctly, but the specifying the block number is recommended because it's more performant. So even so, if you don't have any other specific reason, I would recommend to set the block number for the fork testing. So, we can do fork testing in Foundry too, for sure. So you can set the mainnet, Kaia mainnet RPC URL from the configs, and you can call this create fork method with the mainnet RPC URL. Then it automatically uh, the Foundry makes it automatically execute on this mainnet state. Yeah, you can select fork like this. Yeah, and the next one is fuzz testing. So I already explained about the fuzz testing and the purpose of fuzz testing. So fuzz testing for the fuzz testing in Foundry, you can simply put uh fuzz keyword after this test keyword. So for example, test fuzz on the var set number like this. Then it automatically provide some random numbers uh in this function. I mean in this set number. So you can test with very large number of inputs for the first testing. Yeah. So yeah, that's it for the testing. And the next thing is contract verification. So what what is verification and why do we need to verify the contract? So verification is basically publishing contract source code on explorers like Etherscan. In case of Kaia, we have Kaia scan. So it's basically the same thing actually. Anyway, uh, why do we publish contract source code on Explorer? Because there are some benefits for that. First, transparency. So users can trust verified contracts because there are the contract source code. If you search some contract like DeFi, like some DeFi dApps that you're using. Let's say you searched it on Etherscan or Kaia, and then in the contract section of the uh, contract code section of the contract item, and there is nothing, then you might wonder what is the contract source code exactly. You might you might not sure. You might not be sure how the contract works actually. So I mean as a developer, I mean from the developer's perspective. Yeah, anyway. So if we verify the contract on the explorers, the users, especially developers, can trust those contracts because there are source code verified source codes. And And also we have other benefits like auditability. So auditors can verify logic. So it's actually similar to transparency. So because auditors can verify logic, the logics of contracts, everyone can now trust the safety of the contracts. And also is I think it's minor benefit, but anyway, we can reuse. I mean, there are some benefits like reusability, so users can interact with ABI directly in on explorers, or they can uh, use interact on their other mm, platforms or systems like their local node or whatever. So yeah, that is another benefit. And we have some ways to verify the contracts in Hardhat and Foundry. So let's dive into those things. So in Hardhat, we can easily verify the contract using ignition again. So MPEG's Hardhat ignition verify your deployment. Do you remember the deployment ID that I mentioned before? So it's basically uh, uh, object to identify the deployment items. So after you set the deployment ID when you deploy the contract, and then you can reuse it to verify the contract here. And for Foundry, it looks ugly here, but the key part is this verifier URL. So let's forget about other things. You can just remember set this verifier URL. So it's slightly different from normal, I mean original command in Foundry. So for Kaia, we have to set this verify URL for Kaia scan, and yeah, and you can learn this forge verify contract command to verify the contract. So when you verify the contract, you can see the source code of on the explorers like Kaia scan. So I have some uh, contract item from the Kaia scan is USDT token contract. So in the contract section, like you can check, you can see the check mark. If you verify the contract source code, then you will see this check mark in the contract section. So here you can see the source code, but since the USDT contract is upgradable contract, you can only see the upgradable proxy contract here. You can see the logic contract in other contract address. And anyway, you like what I mentioned, you can see the ABI, and you can directly interact with this contract because we know what the ABI is from the explorer's perspective. So you can read and write to the contract. Yeah, that's it for the verification. And now we will learn the security things like common security issues, vulnerabilities, and how we can prevent them. So there are many vulnerabilities out there, but I only I only brought some core vulnerabilities, some common vulnerabilities. So first one is the lack of access control. It's actually um very easy to forget and misconfigure. I mean, before the deploying the contract, like in this case, there is some board contract, and board contract is just keeping the funds for the owner, and there is withdrawal function, uh, and it's basically withdraw all funds from this contract to the owner address. So, but uh, in this case, there is no access control for this withdrawal function. Anyone can call this function uh, to withdraw fund. So, uh, so it's very, I mean, it's just basic example, but actually there were some cases, real world cases that happened. I mean, in terms of security issues in production case because of this lack of access control. So it could be I mean it could be just more things, minor things, but it's easy to forget. So you must check this access control before deploying the contract on mainnet. And the next one is gas limit DOS. So it's actually a common pattern that you can easily forget about it. So when you iterating over I mean some large enough arrays or performing heavy work in a single transaction, then you can easily I mean exceed the block gas limit. Then it just reverts with out of gas error, and you cannot execute the transaction. I mean you cannot execute the function. So for example, here we have distributed function. What the distributed function is basically just transfer payment for the users. So let's say here the length of users array is very very large. So uh so it when we call this function, it exceeds the hard block gas limit of the blockchain itself. Then we cannot execute this function anymore. I mean, almost forever. Uh, of course, for sure, if we set, I mean, the for in case of Kaia, the core clients can be updated to uh, increase the block gas limit, but in most of cases, we can't. So you cannot execute this function forever because of the out of gas error. When you iterate uh, the large the the large arrays like this. So it's also common error. Actually, I've experienced this when I build some contracts in the past company, and the auditor luckily auditor can find out this issue. So we could updated code to prevent this gas limit DOS issue. So, and the next one is also common thing, a weak randomness. So, it's very hard to generate the pure randomness in blockchain. So let's say you want to generate some randomness from this, like using block.timestamp. And message sender is not that important because is not a random one. So block.timestamp, the problem here is block.timestamp value can be manipulated by the, I mean, block proposer or miner or something. So it's not pure random. So so in most cases, most developers use the VLF function from Chainlink or other random or you can use the random I mean in case of Ethereum the value for the randomness, but when you design some random like airdrop things, you have to use when you have to use randomness, please please care about I mean uh think about care about these randomness things. And the next one is very notorious and well-known um, security vulnerabilities. So it's called re-entrance attacks. So what are the re-entrance attacks? Is basically attacker re-enters the contract during an external call and draining funds. So it's hard to understand the first time, but you can understand by checking this example. So here we have some contract that storing balances variable. So every address can have their own balance, and when some address call some users call this withdraw function, they can withdraw only their own balance. Uh, so here, amount would be the balances of the message sender, and then just transfer the amount to the message sender and set the balance of the message sender uh, to zero because they withdraw it. So you might wonder what is the problem here? You might wonder, but with using reentrance patterns, you can drain all the funds here. So when you call this core transfer core function here, if the message sender is contract actually, and then though the contract is again trying to call this withdraw function, then the execution flow like this. The core function here is executed, but it re-entered this withdraw function, and then it keep repeating this core, executing this transfer core function uh, until draining all the funds. So this is the re-enters attack. Is uh, it's very I mean there was some big security issue regarding related to this re-entrance attack, which is the DAO hack. So I'm not sure what the I mean 2000 maybe 2017 16. I'm not sure, but at that time there was some the DAO contract that can invest to promising projects. So many users in Ethereum invested their money into this DAO contract, but the attacker drains almost all of the funds we using this re-enters pattern or attack pattern. So after that attack, I'm not sure what the exact number is, but almost more than half. I mean, in total, ETH, more than half was drained by the attacker. So the Ethereum community decided to do hard fork to recover those funds. So the who agreed with this hard fork was becomes the current Ethereum ecosystem, but the people who denied the against for this hard fork, I mean those people uh became the Ethereum Classic ecosystem. I mean, yeah, that was the some story about this re-enters attack. So how we can prevent them? So basically, we can use checks, effects, interaction patterns. So basically, it means update store state before the external course. So here we set the so we set the balance to zero after the interaction to the external contract. But here you first set the balance to zero, so update it first, and then you can interaction. Then if even if you re-enter this contract after calling this after transferring the amount, you the balance is already zero, so you cannot drain the funds here. So this is called checks, effects, interaction patterns. So you must first checks, check the requirement and then apply the effects like setting balance to zero and then interaction. So call the external contract. Yeah, that is the basic pattern for preventing reentrancy. And actually, in most of cases, we prefer to use re-enters guard, which is the external like you can implement it in by yourself, but usually we use external libraries like OpenJavelin or Solidity. So you can inherit this re-enters guard contract, and then you can set the modifier here in the withdraw function. It basically set the flag uh, at the top of the this contract, and it prevents to re-execute this function by checking the flag uh, before executing the main body of the function. So so I would recommend you must follow the checks, effects, interaction patterns for sure. And then if you use this the entrance guard with that pattern, then you will be safe from you will be safe from this re-entrancy attack. Yeah, so that's it for the today's lesson. And we have exercise here. So it it would be very it would be not very easy one, but uh please create an ERC-721 token contract, not the ERC-20 token, either hardhead or foundry, which which you prefer. And the 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 key point here is don't use external libraries. Please build from scratch, and don't use OpenJavelin or Solidity like Soulmate external libraries. And so write the contract code, and please writing some unit test codes, and you can test you can use fork testing or fuzz testing. So and then you deploy the contract to the Kairos testnet and verify it. And you can submit to our Discord channel the link of the Kaia scan that you verify the contract that you verified. Yeah, and that's it. So please please submit the link of the deployed contract. Yeah, after the last. Yeah. Thank you. Or yeah, do we have any question
Hi
today?
everyone. Yeah. Any questions do we have? Oh, I have one question for you, Aiden. I'm not sure if this was mentioned, but when is the exercise due?
Uh exercise due is by the next by the I mean next Friday. Yeah.
Next Friday. Okay, so that
Yeah.
will be the 27th.
Yes.
Yeah, due date is June 27th, everyone. So just keep that in mind. Yeah. Okay, cool. Any other questions we have in chat? Please the
Okay.
slide and form for submission. Oh no, there is no form for submission. Basically, Aiden has tasked you all to just submit the Kaia scan link onto Discord. So essentially everyone here should be in the Discord. Yeah, it should be in the Discord. So yeah, all you have to do is just submit the link there. Um, one of our ambassadors is asking, will you still touch on Foundry cheats and show applications?
What do you mean by cheats? You mean cheat code or I'm not quite get the
Yeah, could you kindly cheat codes?
cheat codes. Yes. I think actually you can refer to the official Foundry docs for cheat codes, I guess. I think it really um I think it's not that it does not make sense to make some separate docs or page for the cheat codes, I guess. Does that answer your question?
I guess so, if he's not typing anything more. Hopefully it answers questions. Yeah, probably that answers the question. Anyways, yeah. So I think that's all the time we have for today. Any further questions, please do push them onto Discord. We do have a separate channel for questions. Yeah, we do have a separate channel on Discord for questions. Everyone here should already be in the Discord. If you're not already, please you can. I think the best way probably is to DM on X, I guess, on Bill on Kaya, and we can get it sorted for you. Are you showing how to use Foundry deployments using scripts?
Oh yeah, we already covered it in the slides actually. You can learn like this. Right?
I hope that's what you mean. Because don't worry,
Yeah.
the slides and the recording will be up shortly after this lesson is over. So hopefully everyone gets a chance to review them before the next lesson. The next lesson, unfortunately, Aiden will not be continuing on his streak. He only has this module, because I think Aiden is very, very busy. Drop the timetable on Discord. The timetable is already on Discord, my friend. Anyways, yeah. So unfortunately, or fortunately, if you guys don't really like Aiden, um, you know, he is not going to be presenting again. Next up we have a no demo project or something. Next up we
Yeah,
have no, no, go ahead, sorry.
you can use the starter founder starter project that I've shared already. Yeah.
Yes. So, oh, Aiden's he called you
Biden.
Biden.
I'm the former president.
Yes. Yeah, I think it's yeah. Cool.
Yeah.
Yeah, so next up on our next lesson is next Monday at the same time, 2 p.m. West African time, 10 p.m. PST, 9 p.m. Singapore. It will be on Monday and it will be one of our senior blockchain engineers at Kaia. Uh Aiden here is a senior DevRel engineer. So not really he's more DevRel related versus the next presenter is more, I guess, more ecosystem, more blockchain, you know, in that line of work. So I hope you all are excited to meet him. I think the emails should go out to everyone tomorrow. Because I like to send it out. I don't like to send out bulk emails, otherwise it gets a bit confusing. So we will be sending out the emails sometime tomorrow. The standard EDM that you've been receiving previously. And yeah, the Zoom links as well should also be sent out same time tomorrow. For the next lesson, please do click that link to join. Otherwise, yeah. So otherwise, any parting words, Aiden?
No, I think I want to say thank you for thank you everyone. Thank you for attending today's lesson. Yeah. Yeah, thank you for your time, everyone. Yeah.
Yep, thank you everyone. And yeah, remember to complete your tasks and remember the 90% attendance requirement, otherwise you won't be able to participate in the hackathon afterwards. Yeah. So yeah, if there's nothing else, any questions, like I said, post them to the Discord. Our ambassadors and ourselves are also there. So we try to answer them as soon as we can. And yeah, if there's nothing else, take care everyone, and we'll see you all on Monday. Okay? Okay, bye.
Okay, take care. Goodbye. Bye bye, everyone.